Hey, what's going on YouTube? Adam here with Retro Repairs, and this is, well, not quite a repair video, but I'm going to be building a useful tool for me to help with some future repairs. So what I've got here is a working Nintendo Entertainment System. Just going to power it on, show you that it works, show you that input works, audio works, controllers work, so fully functional system. And what I want to do is take the board out of this and remove all of the chips and install sockets. So the purpose of that is I can make it so that chips like the CPU and the PPU can be easily interchanged, and in doing so I can use a knowingly good system and test out some suspect chips on maybe some systems that aren't known good. So it's really going to be a big troubleshooting tool. So I guess we may as well get started. Alright, so first things first, we need to open this case up. So 6 screws at the bottom. I'm not going to really go through the whole opening up aspect of this. I've done it a few times in different videos, and as this is sort of a little bit more of an advanced kind of, I'm not going to call it a repair, but a job, I'm going to just skip ahead, I think. Okay, so I've got the board out here, and first chips I think I'm going to remove and socket are going to be these ones, and I believe these are the work RAM. Oh yeah, this one's work RAM, this one's VRAM. So I'm going to desolder these. The nice thing about this board, this is a CPU 10 board, so it has these narrow RAM chips, whereas on some other revisions they're quite a bit thicker, and they actually have the holes right here where those could have gone in. So this board can actually accommodate either type of RAM chip, I believe. So I'm going to desolder this chip. I'm also going to open up these holes here, and I think I'm going to try and socket all 3 of these rows. So that will give me the ability to put in a larger RAM chip or a smaller RAM chip. The only difference between the two is the physical size. Otherwise, they're pretty much identical, I believe. So let's get to business here. So first thing I'm going to do before I actually start desoldering, I need to add some additional solder. So I got to get out my solder here. So that will be these pins right along here, and then these holes right there. So I'm going to start out just by throwing some flux on it. Cool. Now, for doing this, the soldering tip I've chosen to use, instead of my normal chisel tip, is going to be this knife tip. And the knife tip is nice because I'm just throwing some solder on there, so it'll hit a few of those pins all at once. So I'm just going to tin this tip, and then let's get a good angle here. And just start on the end, add some solder. Point is, I just want to reflow all these so that there's a nice mix of fresh solder on there. Same thing down here. Add more solder as necessary. And then same thing here. So these I want to make sure that there's a good amount of solder on there because I need to be able to desolder that. Cool. So I have my new Hako FR301. So this is it's a nice little desoldering iron. It's kind of a built-in one, so it doesn't have a base station. It's just built right into the handle. So we're going to get this up to about, I think, around 400 degrees, maybe slightly less than that. And once this red light turns off, we're up to temperature, and we can begin desoldering. So let's see how much we can zoom in here. See if I can get a good view of this. All right, up to temperature. So let's see how this goes. All right, so that chip itself should be fairly well desoldered. I'm just going to give it a quick little check. We want to make sure that those holes are nice and clean. Looks like they're pretty good. So one thing that you like to do with this, take tweezers or your thumb and just want to wiggle these pins back and forth a little bit. In case there's any leftover residual solder, this will help to break it off. All right, so let's try lift that up, see how it goes. So I do have a chip extractor. Okay, so we don't want to lift it too hard. So just give it a light little tug. So we are getting some movement here, but it seems to be stuck on something here on this side. So let's flip her back over and just take a quick look again. Yeah, there we go. I think that should free it up. So the reason that we're wiggling these is if you just grab something and start trying to pry, which I have done before, you're going to rip vias out and then you just got another repair you need to do. All right, so there we go. That chip is out. It wasn't too difficult, and there's no vias or pads attached to that, so that was a successful removal. Let's take a look at those holes. You can see underneath them, they're pretty clean. Doesn't look like, nope, none of the plating or anything's come up, so that was a successful chip removal. One other thing I am going to try and do now is open up these vias as well. So let's see how that goes. This is just a little trickier to aim because I don't have a chip to kind of go through. Okay, so that worked pretty well. You can see all three of those rows are now clean. So yeah, I would consider that a successful removal. So they're going to do the same thing now to this other RAM chip. So I'm going to record it, but we're going to speed through it a little bit. All right, so now let's try removal. So again, very gently. Okay, so we got most of it off. Let's give it a little wiggle, try and see if we can break up any residual solder that might be there. Trying not to force it, because we don't want to rip pads off of this. And there we go. Chip number 2, no vias, no pads. Successful removal. So now I'm going to clean that spot up again, and then we can get to installing the sockets. All right, so now we're going to install the sockets in place here. And the sockets that I ordered, these are they're called dip sockets. So there's a 24 pins. Usually it would say a size on there somewhere, but I believe these ones are 0.3 inches. So they're suitable for the particular chip that I've removed, and this is what it's going to look like right here. So it's just a little plastic connector with some metal pins that are going to go all the way through the board. That way the chip itself can be easily inserted or removed without requiring additional soldering. So I'm just going to start with one of them here, line it up, let it sit in place here. There we go. So that's sitting nicely, and it grabs on not too bad, so it looks like it's going to hold itself into place pretty well. So now let's flip this over, and now we have to solder these rows of pins here. So again, just making sure that it didn't drop off the board anywhere. Going to add a little bit of flux. There we go. Once again, just give that a good push up to make sure that everything is sitting nicely. And clean up my soldering iron, and then I'm just going to tack in each corner first. So heat that up. One there. Come on, there we go. One there. There. And there. So now that that's being held into place, I'm going to go along and actually install all of the pins. So I wonder how good of a zoom we can get here. So I'm going to do a technique called drag soldering. So to do that, I have this knife tip, which is a little bit longer. It's nice and flat, and it will, really it's just going to basically heat up numerous pins all at the same time. So kind of like this. Heat it up, add some solder, and just move along. There we go. So those look all right. Let's go back on the top row and do the same thing. Okay, give a quick peek just to make sure that we've got no bridging or anything, but otherwise that looks to be pretty good. So same thing now for the other one. So let's flip this over. I'm gonna line up the socket. I do want to make one mention of something. So you see right here, there's a little outline of the chip, and there's a notch in the side here. And I'm gonna look just at this one here at this CPU. And you see again, there's a little notch on the edge. Some chips have those notches, and some chips, like the one here, has a little hole or divot or a dimple on one corner. And that's to really signify that that is pin number 1. So this is going to go in this way, not this way. And if it had that notch, one of them actually has both. I believe that's this one right here. See, it has a notch and the hole. So just different manufacturers had different ways of doing it. So just something I wanted to point out. So let's try throw this guy in here. Okay, that one once again is sitting nicely. However, it seems to be a little bit looser. So I guess the holes were cleaner. So what I need to do for this is I'm going to have to hold it in place myself. So I'm just going to load up the soldering iron with some solder first. Let's sit there for a second. I'm going to add some flux to the corners. And then with my soldering iron, already loaded up with solder, just going to tack it in place. There we go. So that's going to free up my spare hand now. Clean that tip. Apply some more flux to the other pins. So now that I can come across and do the rest of these pins. Okay. All right, so that is all soldered in now. Let's zoom out. So now, before we go any farther with that, we just need to give it a bit of a clean. So spray it down with some isopropyl alcohol and hit it with the toothbrush again. So you can kind of dry that a bit with some paper towel. Can sometimes help to get that a little bit drier quicker. Now let's flip her over and install those chips. There we go. So as I had mentioned before, you got to pay close attention to the direction that this little dimple is pointing. So in this case, it's going to be on the bottom left. And we should be able to just push that straight in, just like so. And that should be all right. So you want to make sure that it's sitting flush, that all the pins are sitting in that socket, that you're not kind of bending them out. They do make tools that will help to straighten these legs in case you do happen to bend any on removal, but these ones look pretty good. All right, so that was easy. So I want to give this a little test before we continue. I want to make sure that all of those pins are connected, that all the solder joints are good, and then we're going to do that same thing for the CPU and the PPU. So let's hook this up quickly, give her a quick test. All right, so we've got this all set up. I didn't really completely put it all back together, but just gonna manually test it. Say hey to Kona. Hi, Kona. That's a nice ball you have. Anyways, so I'm just gonna hold it down myself. Power on. And there we go, Tecmo Bowl. So this does work. I'm gonna continue to do the same thing again with the CPU and the PPU. Gonna do it a little quicker this time, as I don't think I really need to document the entire process. All right, so next what I'm going to do is this CPU right here. So again, flipping that over, just kind of get my bearings here. So that's these two rows of pins are going to need to be desoldered. So once again, before I really get at that, I'm going to add some new solder to all of these. So you see how some of these are starting to bridge, especially down here. That's, again, kind of a product of the old solder. So what I am going to do, I'm going to come back and retouch these up, because that's honestly not a very good job there. There we go. That's a lot better. So the flux it really helps to clean and prepare the surfaces for soldering, and it works great at really getting the solder to go where it's supposed to go rather than bridging. So you see, all I'm doing is reactivating the same solder, and it's now staying on the pins rather than bridging over them. So that's a lot better looking. Now time to desolder. All right, so that should be good, I think. So let's give this a try. Hopefully it comes out pretty easily again. Oh yeah, like nothing, like butter. So again, give it a quick visual. No vias, no pads, nothing attached to that. Everything here looks good. So That's a successful CPU removal. So I'm going to do the exact same thing now to the PPU. Probably not going to record this one, as it's the exact same process once again. All right, so here I have my socketed board, and I've put the chips back in here. So I wanted to kind of draw your attention just to one part down here, and this is these work RAM and video RAM chips. So as you can see, I've put half of a socket, so just one row of it, on the row above, and so the actual circuitry on here connects these pins to these ones. So as I had mentioned earlier, this board can actually accommodate multiple size chips. So it can accommodate the 0.6 millimeter one, or 0.6 inch ones, or the 0.3 inch ones like I have on here. So that's why those are there. We have the CPU and the PPU done. Another one that maybe wouldn't be a bad idea to do is this one here. And this is the CIC, or the lockout chip. And this one works, this is kind of Nintendo's way of trying to prevent piracy and non-approved Nintendo cartridges from working. So there is a mod you can do to disable this. You lift one of the pins and that basically makes this no longer work. In theory, I guess that could fail, or if it was damaged somehow, maybe it needs to be replaced, but I don't have a socket for that, so I might have to come back later and add that one. But these are the most common culprits as far as chip failures go: the CPU, PPU, video, and work RAM. So let's throw this back in the shell and just do one more confirmation that everything seems to be working properly. All right, so one more try. This is now with the mostly fully socketed board. So I got my trusty Tecmo bowl in here. Power on. Oh, we got a blinking light. Let's try all the way down. And let's clean that a bit and just try it again. All right, try that one more time. What is going on here? Let's hold this in place. There we go. So I think what the issue was is I have a few of these 32 pin or 72 pin connectors kind of laying around, so I think I grabbed the incorrect one. It just wasn't reading the cartridge properly, but sure enough, it does work. I'm just going to grab another one, give it a quick cleanup, and I want to give this a test with it in the shell just to make sure that we're not going to keep having a fidget with it. All right, so we've got a new 72 pin connector in there. I threw in the cartridge holder, whatever you call it, that clicks down. So let's try that. Power on. And there we go. Tecmo Bowl booting up. So, oops, looks like we are good to go. So this is now, let's reset. Yeah, good to go. So that's the socketed system. So the PPU, CPU, and both RAM chips are socketed and able to be swapped out. And that's going to serve the purpose of testing. So I have a couple Nintendos, and I have a top loader that I've been hanging on to for a while but haven't really been working on in probably over a year now. So now that I have this, I have a kind of a reliable way to test chips to see what works and what doesn't. So this should provide me a useful tool to get started on a couple other projects I've had building up. So that's going to be it for today's video. Hopefully you found it interesting, and if you're thinking of doing something like this for yourself, if you're getting into repairs, like I said, it's not overly difficult, but it does help to have the right tools. So as you saw, I have that hako desoldering gun, and honestly, I don't think I would have been able to do this nearly as quickly and efficiently had I not had a desoldering gun. So you might be able to use a desoldering braid, but I've found myself fighting with braids far too long, so it just does make it a lot easier. But that's going to be it for today. Thanks a lot for watching. Be sure to leave me a comment below. Let me know what you think. Like the video and subscribe to the channel. All of those really help me out with getting more views on my videos. But until next time, thanks a lot for watching. We'll see you next video.